Let's talk about two of the most amazing moons in the solar system, Io and Europa. And they're of the four Galilean moons that simply look like points of light when seen from the Earth. We shouldn't have many expectations of these moons, at least rationally we shouldn't. Both of them are very far from the Sun. Any object that orbits at Jupiter's distance from the Sun will see the Sun as 1/25th as bright as we see it from here on the Earth. Only 4% of the Earth's sunlight, the sunlight that we receive here on the Earth, falls on a moon of Jupiter. And think how cold that leaves that moon. We can easily calculate that the temperature at the surface of any of these moons ought to be minus 260 degrees Fahrenheit. That's so far below the freezing point of water that water is harder than rock, and no chance that anything living would be there in these super frigid places. In addition, these moons are not very big. They're about the size of the Earth's moon. That means that the mechanisms by which a large planet like the Earth or Venus generates mountain building, generates volcanoes, ought to not be present on these little moons. Our moon, for example, has been geologically dead for at least 3.5 billion years, and it ought to be that way. At least that's what we thought for these Galilean moons as well. They're small enough that their heat has gradually escaped. Heat is what drives mountain building and drives plate tectonics and drives volcanic eruptions. So our early expectation was that we'd see none of these things if we looked at these moons. So our expectations, which proved to be quite wrong, were that these moons would be geologically dead, that they'd be super frigid cold, and that they'd be not a very interesting place to look for either water or life. But that's not what we've seen. So let's go from the view that we see from the surface of the Earth to a spacecraft view of what these moons look like. They're real planets in their own right. Here we're looking at Io and Europa passing in front of the face of Jupiter, and let's start by looking at Io. Now, our first good view of Io was in March of 1979 when Voyager 1 spacecraft passed by and snapped some amazing pictures that shocked everybody. These pictures showed 7 simultaneously erupting volcanoes. Everywhere you looked on the face of Io, there were volcanoes going off, and I've just finished saying that it should be geologically dead, and that's not exactly what they saw at all. And there had to be some reason for that. We now understand what the reason was, but nobody had been smart enough to figure it out in advance. Io and Europa also are warmed by a remarkable mechanism that has to do with tides. Here's a view of Io, coincidentally snapped in 2003 as the New Horizons spacecraft passed by. Jupiter took this picture of an erupting volcano, and the height of this volcano, when you look at this from the surface up to the top of that plume, is several hundred miles. Imagine a volcano that would erupt on the Earth and shoot a plume of debris several hundred miles into our sky. That'd be amazing. These are powerful volcanoes, and there's a lot of them when we look at Io. So what's the mechanism that generates? Well, this is the mechanism. The incredibly strong gravitational field of Jupiter pulls Io into the kind of oblong shape that you can see there, stretches it. And if you look carefully, you'll see that this orbit is drawn so that the distant part of the orbit is over here on the left, the close part of the orbit is here. This is a very exaggerated picture of it. But when Io reaches this part of its orbit, tidal pull is not nearly so strong from Jupiter, and the moon relaxes into a spherical shape. When it gets over to the right side of its orbit, Io turns into a very stretched out. So it's stretching and unstretching and stretching and unstretching. That happens every 1.77 days as Io goes around Jupiter. And that's so much that generates a huge amount of internal heat, that friction caused by that stretching. So it's that source of internal heat that nobody thought of ahead of time, and that generates all of the volcanoes that we see on Io. Let's take a look at what it looks like close up. Volcanic plume is what you're seeing here, magnified over on the left side. And then if you look at this volcano just in a different place, we're looking down on it from above, obviously right here. The brown stuff is the plume of debris ejected from there, and some of the ejected material that's fallen down on the surface leaves that kind of circular halo that surrounds the volcano. The hottest places we know of in the solar system are on the surface of Io. If you happen to go to one of these lava flows right after it's erupted, it's a temperature that's hotter than molten steel. It's an amazing hot place just because of all the heat that's generated. So let's talk about Europa, the other moon. And here's a view of Europa that also taken by Voyager. And if you look at it at this top picture, you can see something very striking about it. It really bothered astronomers when they first looked at it. Europa has got virtually no craters anywhere on it. It's a really smooth object. And once we've gone back, and the Galileo spacecraft has been in orbit around Jupiter for a long time, and we've been able to get close-ups. Here's looking right at this region of Jupiter, and we can see that there's a lot of interesting structure in there. And if we magnify this little region, we can see something very striking. This looks very much like a frozen field of ice that's frozen maybe in the Arctic Ocean, where you have warm water, open water during the summer, and then in the winter it freezes. These large ice flows are locked in place, and this led people to suggest that the entire surface may have had some water flow that flowed out onto it and then froze, and that we're seeing the results of that freezing. So the gravitational flexing in the interior of Europa has warmed it, has melted water. It may be melted now, it may be frozen now. In the interior, we're not really sure. But here's one possibility of what it might look like. This drawing, this artist's drawing, shows an ice layer at the surface where Europa is coldest, and that's the white. And then beneath it is possibly a layer, could be ice, but it could also be liquid water. And heat is generated from flexing within this interior. This is the brown as rock in the interior. This is a metallic core, just like Earth and Moon and Mercury all have metallic cores. We believe that Europa does as well. But the flexing warms this ocean and keeps it warm, and that may be what we're looking at as we study this incredible moon. Now think about what this means. This layer of ice is very thick. So thick that sunlight wouldn't penetrate it at all. So this ocean, if it's really there, maybe this is 50 or 100 miles deep, would be a black ocean with heat flowing out from the bottom of the bottom of the ocean layer. So this would be an amazing place for biologists to study, and you can imagine Earth-based biologists are incredibly excited about the possibility that something could live in this. You've got a source of energy, you've got liquid water. It may very well be that there could be living cells or living who knows what within this underground ocean. 2020 is going to be a big year for astronomy. We're going to launch a couple of spacecraft that should go into orbit around 2020. Go into orbit. One will orbit Europa, another one will orbit Ganymede, and we'll get our first really close study of this and our first chance to really see whether this might be in fact what's going on in this amazing moon.